Okay, this is meant to be just a brief solder tutorial to help you get started. We are going to be using a tin lead alloy solder, and you can just tear a small portion of it off. Just is soft enough you can tear with your hands. It's a tin lead ratio of 63:37 with a rosin core flux that helps keep things clean and helps prevent oxidation while you're heating up metals to be joined. The 6337 is known as eutectic solder. It actually goes from liquid to solid state with no plastic state in between. So there's some benefits to that. When you first turn on your soldering iron, you want to have some solder ready, especially if it's the first time that the tip has ever seen heat. So this solder melts at 361 degrees Fahrenheit. I have the solder iron set for 530 Fahrenheit. That might be a typical setting for PC board work. The temperature you use is whatever temperature you can get the job done in approximately 1 or 2 seconds. So really you adjust the temperature based on the feedback as you're working on the pieces. If you have a heavier solder joint with more thermal mass, like 2 thick wires perhaps, or a terminal block, you might have to take the temperature up. And especially if you're doing desoldering, which we'll talk about at the end, you'll need higher temperatures if you're using something like solder braid. So let's see if we're getting there. You can always tell, okay, we're there. Now that coating is very important to get on a new tip right away, so that the tip doesn't start to degrade. You can get some on there. You can always just shake off the excess. Use a blue mat. These are high temperature silicon mats. They'll protect the desktop. So always use those. Now you want to keep that tip protected. So if you're not using the iron for a while, leave that solder on and then just put it right back in the holder, like so. Now to solder anything, you need clean surfaces. So you might inspect them. If they're not bright and shiny, some kind of a scouring pad or we'll polish them up. It's a good idea to do that. Don't use steel wool, I think, for obvious reasons, right? The metal in the steel wool might leave traces of metal behind to short things out. Let me just grab a component here. The component side is here, and if I want to put a little resistor on a board, I'll just plop it on there. Now, one trick you may or may not know if you've done any of this, flare out the leads a little bit, it'll hold itself. It's oftentimes, maybe if it's something that simple, it can just leave it there. It's handy to have something that will hold your workpiece. So here's the poor man's helping hand. That's a very cheap version. There's many versions you can find. Some have like nice magnetic bases and so on. They can get fancier. Another thing you may or may not require, but not a bad thing to have, is some kind of magnification. I could bring this in if I really want to be able to see what I'm doing. I could hover that over the workpiece and solder underneath the magnifying lens. It always helps with your accuracy. For sure, after it's been soldered, you would want to inspect it with some magnification to see how things look. That's pretty typical. So depending how you want to do it, I'll leave the magnifier aside so that you can see the soldering process a little bit better. Okay, I've tried to bring that in really close so you can see what we're going to do next. When I take the soldering iron out of the stand, I will clean the tip by plunging it into the brass sponge. And that is a soft metal on purpose so that it doesn't scratch the tip. Don't ever clean the tip with sandpaper or something that's harder than the actual tip itself. You can use a damp sponge or cloth. the brass, the dry sponge method of the brass is convenient. Okay, then I'll bring the iron here. Now watch. What I'm going to do is what's called bridging. So I'm going to try to increase the heat transfer the minute I touch the workpiece by adding a little bit of solder between the solder iron tip and the lead that I'm trying to solder to the PC board. As soon as I bridge, the heat transfer will happen much quicker, and I will move to somewhere in this vicinity. So I'm going to bridge here, but to get a sense of the temperature of the workpiece, I need to be over here, and that's going to let me be assured that the solder will flow correctly and I'll have a good joint. So let's try it. If I don't do the bridging, it can be awkward. It can take too long to get the heat to transfer. That can melt the glue of the soldering pad of the PC board and cause problems. So let's, I can sometimes even wet the tip of the soldering iron if I want to. I can just bridge a little and then switch over to the other side and then get out of the way. It should take about a second or two. And you know, it's hard to do as a demo. This one, I can't tell if it flowed well. That was too much solder, you know, it's excessive. What I might do if that happens, I can heat that joint up and drag some of it upwards. And, you know, but yeah, so it's a little tricky to do it in a demo style where you're talking and taking too long. Maybe I can do another one that's a little better. I would say that's excessive on the solder. I can't even see. It's so balled up. It's hard to even see if it flowed properly. Let's do this one for you, and I'll try to just do it instead of talk through it and mess it up. Okay, so I'm going to come in here, put some on there, and then transfer over and get out of there. And again, I might have had a little excess solder on that one as well. So, but, you know, maybe sometimes I'll drag upwards and get that. What I'm hoping to show you is a nice concave fillet where you, instead of balled up, it should be concave, sort of like a volcano shape. Maybe we can put another component on there and try to do a couple more. But the key is to get in and out in 1 or 2 seconds. Then you know you're using the right temperature, and also that little bit of bridging to help heat transfer helps speed things up. Let's try another component. I'll put something else on there. Okay, I put an 8-pin IC on here. So I had 8 pins showing. Once again, I don't know if you can see, but I bent one pin and another pin to hold it in place. And we'll try to solder this up. Again, as I withdraw the soldering iron, I'm going to clean the tip in the brass sponge. Again, remember, for soldering, all surfaces, including your iron's tip, clean and shiny. I'll try to do this a little better than I did the other example. So I'll just do some pins here. So that's a much better example. And I think you can see it's not excessive solder. It was quick. The heat transfer happened quickly. And maybe I can buzz down through these. This is the pin that was bent over. There's the other pin that was bent over. That's a little excessive. I wouldn't put that much on if I had that to do again. And let's do a couple more here. Better. Better. Probably should have not drank that cup of coffee before doing the demo. Does relate, doesn't it? How steady your hands are. Okay, another thing maybe to point out is how bright and shiny the finished soldering joints are. They need to be bright and shiny. That's a good indicator that nothing was bumped and that the joint is good. So eutectic solder will tend to be bright and shiny if it's all going well. I turned the board on a slight angle to maybe help see the difference in the soldering joints. This one's probably the best example right here. The right amount of solder. Some of them are a bit excessive. A smaller soldering iron tip would probably help in this case to do PC board work. We have a pretty generic one that comes with the iron, so it's good for PC boards, but maybe not real fine work. Probably would get a smaller tip for real small work. But I think this one works okay. There are ways to get solder off, and one of them is called solder braid. It's just a copper mesh that you heat, you put on the joint, and then you heat it up with your iron. So I turned the temperature up on the iron. I'm maybe at 700 degrees. If I want to desolder something, this is one method. You come in there, heat the copper braid, and the solder should wick right into the copper braid, like so. You do have to be careful not to hang out forever on a joint, because again, the glue that's holding that solder pad to the board could lift off, could be deteriorated, and then the trace lift off. When you're done with the solder braid, you just snip that off and throw it away, and you got a fresh one to start with. That's one method. Another method is the solder plunger. It's just a little vacuum tool. If you can see if I hold it under here, but well, we'll show it to you when we zoom out. But I'm going to take that, and what it does is you have a little plunger that you push down, and then it's ready to retract and cause a suction and pull that solder. So you would melt the solder with your iron and then just vacuum it away. Okay. Finally, there's if you're doing a lot of this, it's worth investing in an actual dedicated desoldering iron. So I'll show you that. Probably will zoom out for this. So here's that manual solder sucker that I had used, and you just push the plunger down and then put it on the board and press this button, and it retracts and vacuums the solder off. And then a much nicer way to do it is with a dedicated desoldering gun such as this. The tip is hollow, and this whole area gets hot enough to melt solder. When you squeeze this trigger, a vacuum pump is activated. So it's very easy to use. You just put it right over the joint you want to desolder, like so. Done. So of course this is the way to go if you have a lot of desoldering to do. One easy way you can get some practice soldering is just to take and cut a short piece of wire, and then we have some scrap PC boards that I can put out, and whether you use a magnifier or not, but you know, you can just put that little piece of wire up through, you know, and then sort of a do nothing solder joint, but you can practice until you feel like you're getting the hang of it, and so on, and just keep at it until you build up your skills and confidence. I have a couple quick examples of what some good solder joints might look like. You always want solder to be flowed all the way around, no missing spots, and not too excessive. So this would be a wire being soldered onto a potentiometer. Perhaps if you had two wires that you needed to solder together. Again, you don't want excessive solder. Let's see if that'll focus for us. You know, but you do want it completely covered. You shouldn't see any bare wire. What that tells you is that you have gotten it hot enough that the solder flows everywhere. It's not so different than a plumber sweating solder into the joint of two copper pieces of pipe. You really want it to flow. The goal is you're not heating the solder with the soldering iron. You're heating the workpiece with the soldering iron and then letting the workpiece get to temperature where it melts the solder. So maybe I could illustrate that. In other words, if I was doing this wire together, maybe I would wet the tip a little bit, but I'd be over here, and then I would be feeding solder maybe to bridge, but then over here to see, has it gotten hot enough? See, it's melting here. And that tells me the workpiece has gotten up to temperature everywhere and that the solder should flow appropriately. That's just burnt flux when you see that. You can use flux cleaner to get rid of that. That's the rosin flux, burnt rosin flux. Some other pieces to look at, well, here would be a battery terminal. And again, let's see if we can get that to focus, but you don't want excessive solder, but you do want it to be sort of flowing everywhere. I don't know if I can get that to show up for us. There it comes and goes. The battery terminal. Again, you can see about the size of the fillet that you're looking for. You don't want it to be a ball or round. That means you didn't get the workpiece hot enough. When you get the workpiece hot enough, the solder will just fan out, and it shows that it has good adherence. Like here's a little test lead. Maybe again we can see if see how it got up to temperature. You can tell by the way the solder has sort of wicked out, fanned out onto the surface, tapered out. Shouldn't be balled up in any way. Should just be smooth, but completely covered. Not too much, not too little. Okay. This is a project we have for you right in the beginning. It'll help with your solder practice, and it's also a practical piece that we'll be using to do some very simple circuits. This is one that just needs tidied up. This would be an example of something done poorly. The idea, I think you can see, we're trying to bring a AA battery, positive and negative, to these rails, and then another AA positive and negative to these rails. And the wiring isn't terrible. It could maybe be a little neater. For example, there's no need for this loop here. And for consistency, I mean, maybe this one could also not be coming out, but just, you just want to do things that aren't going to be in your way later. Now look at what needs to be reworked here. First of all, when I moved this, that's a bad sign, right? That this was it what you would call a cold solder joint. Look, that would never pass, right, to anyone who's looking closely, which maybe that's the key. Don't just solder, but look at your work. So it's not really connected, but it wasn't heated up adequately. It also, you can tell that it also wasn't thoroughly done. There's a hole still there. Here's another example. This one is adhering, but you need to complete that. You can't be satisfied with just that the wire got tacked to the terminal. It can be much stronger. You can fill this in. And if you were a welder, they would just call that a really poor fillet, wouldn't they? I mean, that's not going to be strong, as strong as if you fill this whole thing in. So, yeah, it should be neat, smooth, concave, shiny. Here again, here's a good example of what they would call a cold joint. Somebody did not heat this adequately. Obviously, the solder didn't flow. It just kind of balled up and stuck there. it kind of tacked, but not at all strong enough, and not convincing that it would even be good conduction necessarily. If I had to guess, I would say the person doing that, I'll show you a technique that they might have been incorrect with. I always warn people who are, beginner solderers, don't dab. And what I mean by that is the iron should stay relatively still, and the solder is fed to the workpiece. So the solder is moving, you might feed solder here, 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 and so on. But what you don't want to do is think that your soldering iron is a paintbrush. You don't want to do this. I think this is what might have happened here. Somebody was just maybe poke, they got a glob of solder here, then they poked, oh yeah, wait, I think I got it. And they're trying to melt solder on the iron and apply it to the workpiece, the connection. So it's totally incorrect, right? So maybe let's get a fresh start there. This is rather messed up. So let's get some of this solder off of here. Let's just wick that all away. Give us a nice clean start. Get a fresh start here. The other thing, we really don't want that insulation in the mix, because that plastic will melt and that'll contaminate our joint. So I think we're okay now. Let's see what we can do here and do this the proper way. So I have my iron, and I'm going to bring the tip in. I'm going to wet that a little bit, and I can bridge a little bit for heat transfer, and then I'll just feed. I'm going to jump over here. I'm going to feed. There we go. It's pretty good. I'm going to feed some here. But notice I'm going to exaggerate a little bit here, but notice I know the workpiece is hot enough. Again, sort of if I look, I can feed it way over here, and see, I can see that it's melting. So I'm hanging out there way too long, but I just wanted to show you that again. And notice that the iron stays still. It's transferring heat nicely, and I move around here with to feel, is the workpiece up to temperature? And yes, it is. And then leave it alone, let it cool down. So don't dab with the iron, hold the iron steady, bridge to get the heat transfer. The bridging fills in that little gap of air between the uneven surfaces of your iron tip and the workpiece. So that's what the bridging's all about. And then you move over somewhere away from the iron to be sure that the workpiece is getting up to temperature. Okay. Once you have everything soldered on this little project, which these aren't fixed up exactly, I mean, they still would have work to do here, but the other part is just try to dress the wires in as neat as possible. If you did put the battery holders all the way out to the edge, you should have a little channel that might even work for you to tuck the wires down in here. But try to keep it as neat as possible. And the thing that does for you is it helps things not happen down the road where something gets caught on something or bumped or a wire gets pulled out. So dressing wires in would be the final stage, and then you'll have your little mini breadboard ready for some simple circuits.